Me llamo Víctor Acevedo y bueno, vamos a intentar hacer un taller con lo que tenemos de scripting en la versión 2.0 de gvSIG. Hemos tenido un pequeño problema con mi ordenador y no lo podemos usar, he tenido que usar uno de los que tenemos aquí y bueno, creo que todo está correcto, pero podemos encontrarnos alguna sorpresa, espero que podáis disculparme. Si os parece, podemos empezar describiendo qué es lo que tenemos dentro de la extensión de scripting una vez instalada. No sé si os habéis fijado cuando la estaba instalando en el ordenador que hay que seleccionarla expresamente dentro del gestor de complementos. No es una extensión que tengamos incluida en la distribución estándar. Hay que, en el proceso de instalación o posteriormente, desde el gestor de complementos, seleccionarla y entonces ya la instalamos. Una vez que la tenemos instalada y hemos rearrancado gvSIG, nos aparecerá dentro de la barra de menús, en la opción Herramientas, una nueva entrada que es el Scripting. Dentro del Scripting tenemos tres opciones. Una es el Scripting Launcher, que nos abrirá una ventanita donde tendremos disponibles todos los scripts que hayamos escrito nosotros. También tenemos algunos scripts que hemos introducido a modo de ejemplo y que podemos utilizar para comprobar cómo va funcionando. La siguiente entrada que nos encontramos es lo que es propiamente el editor de scripts. El editor de scripts se compone de una ventana de navegación desde la que podemos seleccionar los scripts que tenemos, también, por supuesto, los del sistema, y lo que sería aquí la zona de edición de los scripts. Y esta parte de aquí abajo es una consola de notificación de lo que ocurre cuando ejecutamos nuestros scripts desde el Composer. Entonces, podemos empezar, si queréis, por crear nuestro propio script, para que lo veáis. Un hola mundo, para no salirnos de la tradición. Y empezamos viendo el programa clásico. Le damos a guardar. Esta es la plantilla que nos genera por defecto. Nos importa el módulo gvSIG, que es la librería que hemos implementado con las funciones útiles, digamos, para simplificar todos los procesos de creación de los scripts. Entonces, una vez que tenemos creado nuestro script, simplemente lo ejecutamos y vemos que nos aparece lo que hemos dicho que imprima por la consola de salida, el hola mundo.
What else can we do? See, I had some of these pre-loaded and I no longer have them because it's not my computer. We can try another script here. If you want to follow this, you can just delete what's on the template. We can copy it and import it from one of the modules we've implemented. This is the Commons Dialog, which is a library that loads dialogues with the user. We can show messages in the gvSIG environment. We can run this. This is an input box which requires a text to be entered. We can say hola mundo, hello world. We click OK, and here is the window with the message that we've entered in the other box. As you can see, I'm running this on a gvSIG environment. So everything for scripting, everything in the libraries I have, and everything can be done from gvSIG scripting. Let me show you the console. It's integrated in gvSIG SIG, and we can show this in an interactive way. If we produce a similar script, here we see that we get a window with a message. Well, the import has not been, I've not done the import well. See, the result is the same. Another test we can do from the console is accessing this layout. We are requesting to this utility library, that of gvSIG, to show us the active view, and we can ask the name of the ladder, and it gives back the name of the active view. So this is a way of seeing that this is easily accessed. If you have questions, don't hesitate to ask. Please let me know. I will upload the script code so that you can play around. Maybe you can access this via some web. We can access this online. That's a problem with changing computers. This is not my computer, so I'm having trouble here. My apologies. Okay, let us move on and see the first script, the one with the windows. It calls our function. At the input box, these are the settings, which would be a string, which is the message, the title, and then a constant, which shows the icon we wish to be shown in the window. And the other function is the MSG box that you might know from other developing languages, and it is you have to enter the settings, the string, and icon. Log onto the following URL so that you can see the scripts. bit, Well, don't worry. We'll show you in a minute.
Los tamaños de letra no los podemos hacer más grandes. Cuando uno está muy al fondo y se le hace duro, aquí delante hay un montón de sitio. A ver, pégalo y ahora hay en editar preferencias. Editar preferencias. Tipografías y colores. Quita el check y usar. Vale, y ponla en 20. Vale. Esa es la URL, bit.li.
So go on to bit.ly/8gvSIG, and then we have and then scripting. Can you put it up again, Victor, please? Thank you. Okay, this is a document on which we can all write, and we will be mentioning the different URLs. What else can we do? Well, for instance, you see I've copied them. They were really in the environment in that computer. So that's why I'm copy pasting. I think I mentioned this. When we generate a new script, we always get the same template, the import of our main module with all the different functions, and a main function. When we produce scripts, you must realize that this function needs to be there, the main function, because the script searches for this and runs what's inside. This doesn't mean you cannot have other nested scripts, but the software requires this function. You have to have everything inside this function. Let me give you an example that might be more interesting. I have skipped one step because one of the things I needed is inside the other computer, my computer. So here you have gvSIG and then the geo module. The latter has all the functions related to geometries. So we have the script. It will create a polygon layer with this structure, an ID field, and a geometry field. Let me briefly explain to you how we proceed. This is the schema, the gvSIG, and here we see the definition of data that we will be using for our layer. Once we have our data definition, we add a field. In this case, it's an interrupt size 7, and the default value is 0. Then we geometry field, type geometry. The shapes need to have this field. Any shape needs a geometry value. We define the root where we are going to save the shape we have created. This case is /bmp. On Windows, this is different. You need to find another directory, the one you like best. Then we create the shape. We save this in a variable called output, and we need to have the definition of data, where it will be saved, which projection will the shape be placed, and what type of geometry is this shape going to use. Then we create a geometry, a polygon in this case. This has changed in the next versions. Most of you don't like surface. The constant will be called polygon. This change is not available in the RC1. Then we add a vortex, which is a point type object, and we need to set the coordinates, in this case 0, 0. We add the different vortexes of the geometry. We add a dictionary onto which we add the values that the phenomenon we're going to add to our shape will need. To our shape, we add the new entity we have just created, and we close and apply the changes. As for view, we add the layer we have just generated, and fingers crossed, we run it. We get no error down here in the console, and we see that indeed something has been generated. We don't know what yet. And apparently it is a square. Can you all follow? Are there questions in the room? All right, let's move on. Has anybody tried to run this and it hasn't worked for you? We haven't heard the answer. This is the interpreter speaking, because the audience is not using a microphone. Apart from that, has anyone ran the script and it has not worked? What is the problem there? Have you tried... Please pass the microphone around, otherwise the sound will not be included in the video and the interpreters won't hear. Yes, I hit run, but I see a progress bar down here at gvSIG, but I see that no views have been created. The progress bar will disappear because it's not indicating that the script is not being ran. It has been run, but it's not showing the real script progress. So the script does not generate a view. The view needs to be there. We could generate a script that could produce a view. This is a bit more complicated than what I wanted to show you today, because I don't have the interface I have. But we're going to work around the objects and things that we have in our computer and in these projects. One of the exercises I wanted to show you, and for those of you who want to go your own way a little bit more, so that you can do so. I am copying something that I will share with you. Another simple script is, let me jump in, same URL, but with a 2 at the end. Same procedure, new script. I forgot to mention this. This is important. It will be written in Python language, but you need to make sure that it's a script. We can generate other things other than a script, and you need to choose the language. This scripting function allows us to choose between Emars, Python, and Ruby. And everything we're doing is only supported by Python. It will not work with any other language. We can also create a script, a form with the form editor, which is included in the extension, or a file. This is the latter is generated in the script area, and this folder, and this not a file but a folder, can be created easily. We were generating a new script, if I remember correctly. Let me tell you a little bit what it does, then we'll run it. It will ask for the root of a file, hence its placement here. We generally don't proceed as I'm going to show you. There is a function in the Commons Dialog module, which is called Dialog Profile. So it will open a window that will allow us to browse through our directory tree and select a file, and it will show us the file root. There's a bug we identified yesterday, so it doesn't work. So we will, through this function, we will write this manually. If we do not write anything there, there will be a message that will pop up saying that we need this. We'll see that the path exists. If it does exist, we will see where it is exactly. We run it, it asks for the path. We click OK, and there's an error. And where's the error? Right here. This is another function. There's a syntax error. We need to open and close parentheses, which shows us the folder in gvSIG that collects our cartography or maps. I don't know whether you have modified the preferences. folder. We can establish where we want our projects to be, our data, the templates. This will give us the path without having to do anything else. I think it is much more convenient. In this case, we don't know. We don't need this. We will not be using the preference folder. We're simply using TMP. Another arrays, you have the path root here. It mentions that the variable I was using had not been previously defined. Okay, finally made it. We have it has gone through the CSV file and has showed us the contents. It's a very simple script, and it allows us to search through the information in the system, and this allows us to move on to a different script. So if you wish to follow, I'll tell you a little bit more about this in a minute. This script, this exercise, is the result of a post in the user list of Gustavo in a consultores. Okay, I need to I need to explain this a little bit more. So Gustavo suggested a tutorial that he had generated on how to transform a path he had into a polygon. He did this with gvSIG and explained all the steps in great detail on what the mathematical operations and steps needed to be followed to attain that polygon he wanted to produce through a path. I thought this was highly interesting to take to script because we can compare our code, the code we've used for a given script, and the steps that the graphic gvSIG environment has used. This is a little bit more complicated. I have 200 lines. Normally you can do this in less and fewer lines because there are many comments. Jorge will upload the code, and I'll try to show you. As you see, I apologize once again. This was absolutely prepared. But as usual, something has come up. there's a folder with all the explanation. While I look for this information, you might want to ask questions.
To bring the code with all the different comments. Yeah, I have a question. In those libraries that you are using, the entrance point that you're using are put together in a file or in a document where we can have access to them. All those that you're importing, all these descriptions. So you're talking about a document that's a kind of reference guide. Well, that reference guide is done. It has not been published yet. We still have to bring for the last changes, the last modification. Well, and I hope we'll to publish it next week. So we will have a reference guide. We will hope that we will have a developer guide too, and an embedded module in the scripting with all the different functions of the code. It's a bit more complicated, a bit more complex, because we want to give the Python information a Java doc function, well, in order to be able to process all that. And we will have all the available functions for each and every module that we are using, with a pre-explanation of what it is doing, what are the parameters used. It will be a true reference guide with the data structure too. Yes, with that reference guide, any developer will be able to use it and to create a script, to generate a script using those libraries. For users that are not developers, well, they would need something more than the reference guide, because it's not an extensive explanation of what it is doing or not. It's just a catalog. So we will try to publish it, as I was telling you. We will try to publish it next week. Thank you.
A ver si llegamos.
Sí. ¿Tienes otra pregunta?
Hola, buenos días.
Buenas.
Quería preguntarles.
Good morning. I wanted to ask you about the treatment of the DBF table. What is the treatment that you are using? Are they lists? For example, the DBF will have digital and analog data, so can we use the RView? Well, I don't know how RView is treating those data. We are going to ask the entity what are the values of each and every register. We can treat them as a table with the same properties of the object that has been loaded in gvSIG. We can have access to the values, to the parameters, with the type of values that has been defined. If the field is a digital field, when we are asking the entity about the values, well, it's going to give us, well, exactly the same value. If it's a chain, it will tell us that it's a chain. If it's a list, I will get a list. So the type of data that we have defined, and if we are asking the entity, we are not in DBF, in that case, we are in a shape, well, we always get, well, the same structure as the one that we are asking to the entity. I was referring to the fact that if we are looking for a geometry, for example, the number of a street is 25, and if we are trying to find it through geometry, could we have the information in alpha digital or in any other format? Yes, we have a filter. It's a filter that we are using according to a DBF table, but if it's a layer, we would do it immediately on the layer. So we could simply access to the function, telling it that, you know, I need these parameters for this function, and we will get the information that we need. That's very easy. Thank you very much. Now, now I will give the code to Jorge. It does work now. So it's an exercise that has been done by Gustavo. The objective is what he just said, is to have a polygonal study of well, the plan. We have different data, different coordinates here, and we want to obtain a shape. In this case, well, we have a polygon. So what are the steps that we are going to follow? We are going to create the shape file with some data that you can see on the screen. You see that half of those data might be useless. Well, the first time that I generated the script, it didn't work. We didn't get the geometry that we were looking for, and it was very difficult to validate and to discover exactly where I committed a mistake. Maybe I didn't copy very well the data given by Gustavo, so I decided to have a point shapes, and for each entry, I decided to translate the register that I found in the RSV with a converted angle and with the distance, that is to say the data given. So the angle that I have calculated and also the coordinates xi of that point. Those data are obtained through a file that Jorge is trying to share with you so that you can use it on your own. So we see here the different route, the different path, and we see the different origin coordinates, the different relative points. So we see here the different coordinates, the value that we are using for P. So we have 6 decimals. And that's it. It's very easy. So now I can explain what are the different steps, and then we will see where I committed a mistake when writing it. So you see, this function is not the one that we see here on the screen, so we should write the path by hand. So here we have 2 variables. These are 2 dictionaries. We are going to introduce the data that will generate the points. It's our support layer. And the final geometry that we are trying to find, that is to say the polygon that we want to create, we want to generate. We are loading those points. We know them very well. And we get the CVS. So we have to control that the CVS has been loaded, because if we don't have, well, the CVS, then, well, we would exit the script. So we open the file and we can read it, and this is what we've seen in the previous screen. Here with this function, we have a module function. We can create point layer that we are defining here. The main code is in the main function, and I have some support function there. Not to make it too complex, well, we are creating a scheme with the different data. I'm loading the values that we are going to use. I'm creating the shape, and I go back to the main function. I'm doing exactly the same with the polygon layer. So I have created the polygon layer. You see that the function is doing what we have seen on the screen. I'm creating a polygon-shaped geometry, and I'm creating my first point that my support point layer is going to use, and the polygon is also to use it as a vortex. So I'm adding to the geometry a vortex. It is the point that we have created, our first point. I'm loading in a dictionary the different values of the geometry, point type, and to that point layer, I'm adding the entity. We are adding the entity that we have just created. So we are starting to read the CSV. So it's our CSV. We know our data structure, and, well, the first line is the header. So this is what I'm going to use right now. I control to see that I'm calculating the X and I's, and through the console I will get the coordinates that I'm using. I get the radio, that is to say the distance, the radius, and here I have a function that I have defined to obtain the relative point. In that function, I need to include the distance, the angle that we have calculated previously, and the previous coordinates too. The 2 radian function is giving me the radius that I have calculated. I'm sure that you can control that value very well, because you can calculate mathematically very easily. And I get, well, the coordinates, so that I can calculate the relative coordinates. I take the radius, the X, the Y, the angle, in order to calculate everything. Once we have the coordinates of the points, we are loading those values in the dictionary. It's a Python type data. We are creating a geometry, a point time geometry with the coordinates that we have received. We create the entity, we add it to the next point. We add that point as a vortex to the polygon type geometry. So we are doing it for each and every line that we have in the CSV for all the points that we are using. Once we have finished the CSV, once we have read all our points, we are trying to find a message, well, to see what is our error margin in comparison with the initial point. So we are using relative points. We are using, well, all the details or the precision, but we might have an error. So this is what we will see here. There is also another function here. Other dialog uses for the user, and it will ask us if we want to confirm what we have generated or not. If we want to close it, it will create a point with the values of the origin point. It will be added to the polygon that we are creating. And if we don't want to close it, well, it will jump over this step. Once we have created our polygon, we are adding the values to the entity, and we load them in the polygon shape that we have created. We are creating the editing of our layer, our polygon layer. We accept the changes, and we do the same with the point layer. We close the reading of the file, and we can run our script. I'm going to change the source from which I get the path. So you have seen that we've had to change it.
A ver, resulta que no o sea, estáis quedando sin conexión seguramente, igual que yo, por eso he bajado buscando a alguien con ordenador para copiar el script.
So you can copy your script, but now with the network that we have in the room, with the internet network that we have in the room, it's not working very well, unfortunately. So I'm sorry, in the URL that I sent you, I will copy all the links, but right now we cannot access it. So right now it's very difficult to access them, so sorry for that. So don't think that they are running the script on their computers right now because, well, they cannot do it. Well, this exercise will be posted on our blog so that, well, you can do it at home without any problem. I hope that we will be able to post it next week too. So next week will be the week. So once we have changed the path, so I'm changing the route where we are going to save the 6 new points that we are creating. So with some patience, I'm going to give you all the scripts so you can have them because, well, internet is not working properly.
Sí, creo que sí. En principio sí. Si no, las pedimos. Vale, pues una vez modificadas las rutas.
Once we have modified the path, we are going to test it. So according to the standard, we shouldn't do what I'm going to do now. So once you test your script at home, so follow the standard, don't do what I'm doing, import only what you're going to use in the script, not, well, to put some, not to trouble, well, the script in itself. So inside the module, the gvSIG module, we have a function saying create gvSIG. If in the script I'm creating a function with the same name, then we would have some problem because, well, the names spaces would be a bit too full. So what I'm going to do is not what you should do when generating a script. So, but now we are going to take some risks. So what we are going to use will be properly loaded. in theory, we have studied the full CSV. It has generated what we ask it to do. Through the console, we have the control print with the XI coordinates of the geometries that we have created. And it is informing us that we can close or not. Where here we have a deviation of 0.05 for X and 0.2 for I's. So we are trying to create a polygon so we can close it. So I close this view because it is projected well elsewhere, and the script that we are generating is using another projection. So I shouldn't accept, but well, I will do it anyway. So we are looking for the shape that we have created. They should be here. Yes, they are. So we have the polygon that we have created before. We have the other one that we have created with point and the polygon. And we see that it has created the point layers with the different inputs that we found in our file. If we select the table associated to this shape, we see that the data structure that we have defined is there. The distance, the radiant that we have calculated, the X and I coordinates of each point. I know that, well, this layer has only a function of control. So we might think that the radiant is not useful. Well, yes, it is, because when I'm looking at the table, thanks to that, I can see where I have committed a mistake. It's a sole function. And here we have the geometry that we have created following that course. So I have no network either, so I cannot go to Gustavo's blog and show you that it coincides with what he has done. If you have internet on your computer, you can surf the web and find his blog, and you will be able to check that the course and the geometry that we have created are correct. It's much easier to use the script to do this. When you can read the post written by Gustavo, you'll be able to decide, well, how it is more convenient for you, if you want to use it as it has been designed, or to use your own script, well, to do the polygon generation. I don't know if you're trying to following, if you have accessed the sources, or if you have any question on that, or any doubt about what we've done up to now. In relationship with what we were saying before, how can I... Well, we are going to try something. We are going to play with the commandos interpreters console. If you have been working with Python, well, I'm sure that you have activated the interactive console. It will help you to check things immediately. If you have any doubt, any problem, well, you can test them. It's a console that we have in the scripting extension, and it has an advantage. It shows a support, a help about what we are doing if it can recognize the object. For example, we import our main module. We obtain the layer that we want to get. Well, we select the point layer, for example, giving us more data. and we will request to have an access to the active layer. So we have a function opening the active layer, and I wanted to show you that when we use that function, we have a little window, a help window, with the document information about that function in the code and the parameters that it's going to use. So here the function is covering the layer and it's opening the active layer. If we don't have a view in the project, it will design it for you. So here we have a layer that has been loaded in that variable. So what can we do with that layer? We could, for example, have a look at all the phenomenons. The feature function admits the expression that it is a chain that will be compiled, and we can do a filter. The second parameter that we would receive if we want to sort it, it's a connection of phenomena that we get, and we will see if it's an increasing or decreasing. So we have a collection of phenomena included in our layer. So we have a look at all these phenomena. And we can print and we are going to print it. So here we see the phenomena inside the layer. Well, the field that we are using, the ID field, we have 2 ones, and we have 58 registers, and it seems that it's working properly. Well, some people might be dubious, but we can try with any other field. With that, you can check that I have access to what I have loaded in the view. I can manipulate it. I can have access to all the different data. Well, they are embedded in the script, so there's no problem when having access to them. Let's try to see if it works. So let's try to generate a filter with a radius of 50. We are requesting all the phenomena in our layer with a ID over 50. So you see, we only see the IDs from 50 and over. I don't know if you have any question about that, or if you prefer us to show you more things. I'm trying to do some, I don't know if you're doing any of the exercises and you got lost. Well, I don't know.
Si os soy sincero, pensaba que el ejercicio de la
I thought that the polygonal exercise was going to be a bit more entertaining. Well, I'm a bit surprised. Other surprising thing or the curious thing that we might see here with those exercises. As always, we are creating a script, we generate it. I don't know if you've seen it, but I have not tried to manipulate the data of the layers that we have loaded in our view. Well, we are using gvSIG 2.0. The RC has been issued yesterday, so right now it's not being produced, so it's not under production. So we should not manipulate the data. We should copy them to avoid, well, inconsistent data. This is why I'm always creating new layers. I'm not manipulating the data directly. I'm not modifying the table either. We can do it. All the tests that I've done have been very positive, but the RC1, well, was issued yesterday, just for you to take this into account. So what are we going to see in this script? We are going to create a point cloud in this bounding box that we have created. Let's have a look to see if I can find a funny layer, and I will be able to show you what are the steps that we are going to follow. First, we get the layer that has been loaded in the view. We have seen that function. We ask the user of our script how many points he wants us to create. If we have not introduced points, well, then we will say, I have not introduced the required point. We need more points. We calculate the extension of the layer. We calculate its projection. We create the data definition of our output data, where we're going to save that output layer. We create a shape. We use the parameters. As always, we have the definition of data, where we are going to save, what is the path that is going to follow, and what is the geometry that we are going to give to that. We are using one of the standard modules of Python, the random module, to create inside, well, that margin that is defined by the extension of the layer, to make sure that in that range we have a coordinate, an x coordinate. It's a random coordinate. We are creating the point with the random coordinates that we have created. We create our entity. We add our entity to the layer that we have created. We close the editing of our layer, accepting the changes, and we add the layer that we have created with our points to the view. So we are going to load a new view.
A ver si tengo alguna capa un poco mejor.
Trying to find a better layer. I'll use this one. We run the script. Well, something wrong happened, as always. So the section that we see here,
Efectivamente, como veis, tengo que tener la vista. Lo que le estoy pidiendo, efectivamente.
yes, I need the view, and I want to get the active layer. That function is requiring the active layer, and this is why, well, the script is not working out very well, and we have an error. So now let's see if it works better. I don't know why, but we are not getting the active layer.
Por si fuese un problema de que había varias vistas, pero no debería ser.
So just in case we had different views, yes, I had different views, and this is why he didn't like it. It was a bit difficult to find the correct one. Well, we are going to create 200 points, for example. So it has run the script. We have the layer. You have the view here, but sorry, the layer. And it has created a point cloud. We can try to have a more interesting view. We could do it with a point cloud, but it might look useless, and what we really want, this point cloud, I will get rid of the layers because we are going to do it differently. We are going to make it a bit better looking. So this script really looks like the other one with only one difference. We are going to use the phenomena included in the layer that we loaded. We are going to obtain the geometry of those phenomena, and we are going to ask the geometry if the point that we are creating is inside it. We don't want our random points were located outside. We want them to be inside the geometry of the layer. The only peculiarity that we find if we compare to the other one is that if we have a point cloud that's too wide, it won't end before including the random 150 or 200 points that we want to include. When I've tested it the other time, I decided to use the InterSay model. When running it, I asked for the script to create more than 1,000 points, and the generation of the script has been very, very long. And curiously, the layer that I decided to use had not that geometry, so it took too much time. So we need to introduce a control number to be able to exit even if we have not completed what we wanted to do. So it will show how many points he has been able to generate as it was requested. So we can try to find a layer, provinces, for example. So this looks good. We select the layer and we try to run the script. How many points? Well, I don't know. Let's try 200 points. Well, something wrong happened. It is complaining.
Todo esto, claro, estaba en mi ordenador y yo en mi ordenador sí tengo
Everything is perfectly established in my computer. I have my preference folder, and this is not my computer, so we're having some problems here. Let's see the path. We run, how many points? Let's say 200 again. This would be the control. Of course, this is still underway, hasn't completed the process yet. We tested this yesterday with fewer points. It managed to enter the 200 points in the geometry. It has needed 627 points to introduce the 200, and this is the print that mentions how many entities have been entered. Let's see our shape, where we told the software to save this. It's /TMP. No, random points. We load this. Let's see if I can use a color that might be easier to see. White, perhaps. I don't know whether you can see all the points. Is that better? All the generated points are in the polygons in our layer. We have access to each phenomenon of the layer España, Spain, provincias, provinces. We see that the points are contained. If they're outside, the point has been discarded and a new one has been generated. Any question? Should we move on? I'm running out of examples here. Jorge is mentioning that he doesn't know whether we've paid special attention to the fact that we can access all the methods defined by the object. Let me show you this via the console. What I showed you in the console earlier Let me see. Capital letters. I was saying this because that contains method, that function in the geometry, is a feature of functionality. There are others. And Joaquin, just let me know if I'm mistaken, but if you know about developing with gvSIG, there is a functionality that is available, not only the contains method, so you can do more things, not only what we're seeing today. If we go a little bit beyond, when we created these modules, these libraries, the commas or geom, is trying to simplify the Docker parts of gvSIG developing. We realized that to create a shape, we had to call a function and introduce 5 settings, and it requires 30 code lines, but they just run tests with the settings or parameters we've introduced. So we are showing the script generators a function. So let me explain this. We can say, we call we'll say, okay, layer. This is a Python object created in the gvSIG module, and the functions have been defined by us. This is what we believe is mostly used in a layer. So it could, by the scripting consumer. It doesn't mean the layer only has this, but it's defined within the gvSIG API. I don't know whether this clarifies or not. There is further information about this, and if there you see a gvSIG API or API, you will have a link to greater information. We will try to have a description of all our description of the scripting, but we cannot document everything inside. Maybe I went off on a tangent. We were explaining how to generate a new script. All right. We generate a new script. Let me tell you a little bit about what we're going to do next. This I have not prepared. So anything can happen. As usual, it demands the active layer. We get the features. We have the entities or phenomena. We obtain the geometry of each phenomena. Let me tell you what we intend to do prior to exactly showing you how to do it. We are going to try to create the convex hull of this layer called Spain provinces, España provincias. Convex hull is a function that is defined. See, geometry has one such function. So to be able to see in on a polygon layer, I thought that maybe once we have the geometry, in this case a polygon, we see how many vertices for each vertex. We get the coordinates. So we load, we have here the x coordinates and y coordinates. We create a multi-point type geometry, and to such geometry we add the coordinates of the pre-calculated vertices. So it's requesting two parameters, an x list and a y list. Hence, we could have entered the points directly, but anyway, once we have our multi-point geometry defined, we have this convex hull. Okay, let's call this geometry X. We add the values of our new entity, and to clarify this, I have a predefined function with the 4 code lines we need, which are repeated over and over again. Path, projection, data definition, and the actual call. We have another function which is create DBF to create a DBF table. The syntax would be very similar. We add the geometry we have created to our layer. We click OK, we accept changes. And we free the phenomena from the input layer. This is important here. When we define the entities through the feature method in the layer, once we stop using, we have to free it through the disposal method. Otherwise, we will have some scattered points, and if we generate our script, it might done the operations, and we go to the graphic view and we try to edit. There will be 2 different cursors, different, and might be inconsistent then. Okay, we have the active layer. Let's try this. We run it. It shows that the script is being run, scripting completed, and if everything has been done right in our temp file, we must have a shape called convex, which contains the convex hull of our layer. Let's see if we get lucky. Apparently, we have what we requested. Do you want to have more information? Do you want an example, or would you like more info? Good morning. How can you use a different background to the convex hull? Well, as regards symbols, we don't have an easy access from the scripting extension. So from the extension itself, we cannot change the symbols in an easy way. As I mentioned, if gvSIG can change symbols, we can change symbols. But the process of actually doing it is not as easy as writing a function and establishing a color. So this is the default color, right? Yes. Any further question? Thank you. Good morning. Is there a way to include an icon in the toolbar to run any of the scripts we have generated that is not something in the scripting extension? This is something I wanted to explain tomorrow, but yes, that has been thought of, and in principle, you will be able to put a button in the toolbar to run our scripts. As I mentioned earlier, there's an easy way to launch, to run our scripts. These are the ones we've produced here in our workshop. They're right here in the list. And if we click here, double click here, it has executed, it has run the layer. I don't know whether you can recall the actual exercise we did, which was creating a square, and there you have it. We are indeed thinking on how to redistribute the work performed with the scripts. So once you have a functionality, it would be neat to be able to share this with colleagues. So we're actually seeing how to package scripts and distribute them as with other possibilities in gvSIG. This will be explained in detail tomorrow. There's much more to learn tomorrow. So we're seeing how this can be shared through the complement manager. This is not easy. We're actually working on this because we think it's interesting to be able to share scripts. Similarly, the functionality you're seeing in the scripting is data access, and you asked about symbols. What we are interested in this project is to learn what parts of gvSIG do you wish to script, because we don't want to do everything from the start. You know that Victor asked in the blog what you were more interested in. So the more people ask one thing, as soon as a number of people ask for one thing, then we'll go ahead and do it. But you need to be able to develop in Java with gvSIG. So we need to this requires prioritization. We cannot have all the scripting possibilities in libraries. Can you try to go online again? No network. Okay, if you look into the gvSIG blog, there are interesting posts. And I don't know, maybe we can have questions in the user list. Oh, you've been able to go online. I think there's another question. Is there anybody else who wishes to ask a question? I'm afraid this lady is not using a microphone, so we can't hear what she's asking. Yes. Let me show you again. Could you repeat the question? Yes, she's saying that the launcher is not showing that the script is being run. We realize that it has been completed because the layer has been loaded onto the view. This one here, we run it and you see nothing happening. Remember that when we ran the Hola Mundo, Hello World, it was showing the text down here in this box, but the script launcher has not given us feedback about whether it's been ran or even whether this has been performed correctly or not. It's the script launcher is just a launcher. It does not interact. So that could be the responsibility of the person producing the script. But there are other scripts that can be part of a chain, and you don't want too many messages. Maybe we could have the same thing as in the console down here. If you need feedback, if you need to learn what has happened with your script, you should maybe launch it from the edition view, with the edition view, because here you see it says running. If it has been completed, it will say so. Down here you see it says quit, and any mistake will appear. Please wait for the microphone. We hear you, but there are interpreters trying to hear you, so please be so kind as to use the microphone. Is there no process dialogue? That is true. And maybe having a dialogue at the beginning and kill it at the end? Well, I think we mentioned this earlier. You mean a sort of a progress bar? Yes, so that you can actually see what's going on, or maybe launching a dialogue at the beginning and killing it at the end. This is not actually a scripting thing. It's an issue of the gvSIG environment. I'm sure somebody else can answer your question better. The person responsible of gvSIG. Hello. In principle, it has been designed so that the script can report the progress. That little bar on the bottom right hand side is a first attempt. The script nonetheless needs to communicate its progress. So there are some global variables that are being developed so that from the script you can tell the program 10%, 20%, so the little bar will not move from side to side as you're seeing right now, but will tell you exactly the progress. And once the task has been completed, the whole bar will be filled, and it'll say 100%. We're still running tests, and it's not ready. Hence, Victor has not been able to show you. Maybe we could have a process manager to see the progress of the different scripts that you're running. This, I'm sure, will be available in a few weeks because I tested this a few weeks ago and it worked, but I want to double check everything before I release this. Microphone, please. Microphone, please. Let's repeat the question because it has been asked without a microphone. So when I run a script, the idea would be whether to avoid running the script again. Sometimes you're running a script, you forget that script is being ran, and you double click on the script again. So maybe it would be interesting to prevent one same script to be ran twice. Well, maybe all of these scripts are ran on a badge or on a string. So I didn't think that maybe there could be a process there, and I don't know. We might add a check to the script properties. I don't know whether Victor showed you, apart from the code, the code section, and maybe it might say, well, you can't run this twice, so that the user, when when using the script, can realize whether it's already running. Or well, Joaquin has mentioned this. We can define the name, and once we've generated this, we can change it. So you can simply save this, and this is being saved in a file next to the script. Any further question? Other questions? Otherwise, we can wrap it up. Jorge is suggesting that I show you a script that we have developed. This is a clear example of works in my machine. I haven't tested it on this computer. Well, let me find it, because we thought it would be interesting. Bear with me for the moment, please. This is not a big deal, but I've seen it in several bids as a functionality that needs to be implemented. So it's really straightforward, and it can be performed easily without the need of a plugin in Java.
creamos un script nuevo.
We generate a new script. This is the properties window. We click OK. This is our newly generated script. Save, where the properties are not there yet, they're the features. We copy code, save. All right. Well, let's try to open in OpenStreetMap and Google Maps what we have loaded onto our view. I'm going to remove this. Say you're browsing, you have a map, and you want to see on Google Maps, Street Maps, or whatever, what have you, to see what is actually there. I promise I've seen this in bids. All right, let's see the street plan of Valencia, a little advertising of the hometown. Let's try it out. They're saying, be careful with the projection. This script seldom uses the utilities that we have defined ourselves. It says view, and we have to enter this piece of information, and I'm sure it's not going to work, but here in the geom module, you have an easy way to access the projection. The rest would be pure Python language. These are the contents defined by Google, and we have nothing to do or say there. To see what we've loaded, we simply save, run, and something has not worked well. This function is defined in the new version of the geom library. It's not available so far at RC1. If we want to interact with the projections, that would be the easiest way. It's perfect for the example I was saying. RC Factory is a type of gvSIG which has CRS. We've removed the CRS factor. We think as user, as a script, we think the script developer doesn't need to know the gvSIG projection factory. This is something that should be underlying, and that the consumer does not need to have that piece of information. The user will just require demand a projection. So we have created an underlying module, the underlying development, so that under the geom module, everything is ran without the user necessarily seeing it. Anybody knows the chain? I do have the new library, at least part of the code. I had tested this with my own library. I don't need this information. So I'm saying here that I'm interested in CRS class. So it should work now. If we have internet connection. We haven't predefined the browser. I promise it works. Loaded view, CURL. It's not responding. The script calculates the stamp we have and requests the URL and opens the browser, the gvSIG function for browser. Well, apparently it works well, but we see nothing because it's not reaching the browser, so I cannot show you. It seems the URLs are correct, so I've set a print within the script running to see if there's a mistake in the chain. Apparently the URLs are correct. Here it says call browser control. There's a problem because it's not opening this up. I've copied the new URL and copy it onto the browser. Let's see if we could get lucky. Yes, it is, and the calculated URL is correct. Maybe the problem is that there was no network. Apparently nothing is loading. Jorge got it right in the computer you cannot see. See, I'm just copying the calculated URL and opened it using Google Maps. The script is correct, and I don't know. This line, the problem is here, this line calling the gvSIG control in the browser. I think I've showed you what I had. I've showed you what I had prepared for this morning. I think I've explained even more things, but anyway, questions? No questions? Well, thanks for having attended this workshop. I hope it has been interesting, and as Jorge has mentioned, Anything you believe we should work on, please let us know through the mailing list, through our blog. So thank you.